X is the cards. You have cards numbered 1, 2, 3, and 4. Notice if this was a lottery problem or a raffle problem, you'd have net gain, but we just have cards. Probability of getting each of these cards. There's 40 cards altogether. 10 of them are 1s. So the probability is 10 out of 40 that you'll get a 1, which reduces to 1/4. Same for 2 cards, or same for the card numbered 2. The card numbered 3, there's 15, so that's 15 out of 40. Or 3/8. There are only 5 cards that are 4, so that's 5 out of 40. Or 1/8. Then do the X times PX column. I'm going to change to decimals at this point. You could keep it fractions, that would be fine. Next, the X squared times PX column. So X squared, I want to do 1 squared times 1/4. Then X squared PX, I want to do 2 squared times 1/4. 3 squared times 3/8. 4 squared times 1/8. To find the mean and standard deviation, go to your green formula sheet, find the section for chapter 5, and find probability distribution. Mean of a probability distribution is sum of the XPX column. Standard deviation for a probability distribution is this formula. So let's start with the mean. I need the sum of the XPX column. So let's sum these numbers, find the sum of the XPX column. That's my mean. On average, you're going to get 2.375 for a number of cards. Standard deviation, a little bit trickier. We need the sum of the X squared PX column, so that's this number right here. So I add these up. That number goes right here. Minus the mu squared. Well, there's our mu. So that is what you punch into your calculator to find your standard deviation. A study conducted by a TV station shows that the number of televisions per household, so the X's, these are the number of TVs, and the probabilities that correspond with each. So these are the probabilities. So the probability that somebody has 1 TV in their house is 0.32. Probability that they have 2 TVs is 0.51, and so on. The problem says, find the mean and the standard deviation. So I go to my formula sheet, I find chapter 5, and I look for probability distribution. What's the mean of a probability distribution? And I write down the formula. Standard deviation of a probability distribution, and I write down the formula. So I need to fill these out so that I can find the sum of XPX column and the sum of the X squared PX column. So I'll fill these numbers in now. I've filled in my table. Now I should be able to find the mean and the standard deviation. The mean is just the sum of the XPX column. That's that. Standard deviation is a little more work. Square root of the sum of the x squared px column, it's this, minus the mu, 1.9 squared. So I put that in my calculator. There's the standard deviation. Let's think carefully about our x here. We want to know kind of the value of that x. So there's a couple things that can happen. You could get a 2 or a 12. You could get a 7, or you could lose. The x is going to be your net gain on this. So if you get a 2 or a 12, what do you win? Well, you win 20 bucks, but it cost you $3 to play the game. So what you're actually winning is $17. If you get a 7, you win $5. But actually you paid 3, so you're really only having a net gain of 2. And if you get anything else, you lose. So you have a value, you've spent negative $3, or you've won negative $3. So now let's try to figure out those probabilities. We know when you roll 2 dice, there's 36 possible outcomes. Figuring the probabilities. Go to your formula sheet, look at the sample space for rolling 2 dice, and find what's the probability of getting a 2 or a 12. There's 2 choices. You can either get a 1 or a 1 and a 1, or a 6 and a 6 out of 36. So 2/36, or that reduces to 1/8. What's the probability you'll get a 7? There's 6 choices that add up to 7, so your probability is 6 out of 36 that you'll get a 7, or 1/6. So if that is winning, you've got 8 out of 36 that you win. How much are you going to lose? Well, your probability that you'll lose then is 1 minus that, or the rest of them, 28 out of 36. Then you multiply x times px. 17 times 1, 8. This should be an 18, sorry. 17 times 1/18, 17/18. X times px, I'm doing these on my calculator, 1/3. Negative 3 times 7/9, negative 7/3. Then to find expectation, or the expected value, you just sum the xpx column. There's the xpx column, so we just sum these. Remember that you're adding in a negative here. We get negative 1.06. I used the toggle button to make it into a fraction because or into a decimal, because I want money, the amount of money. That means that on average, people lose $1.06 on this. Or the people that are doing the game make on average $1.06 per round. That doesn't mean that they make $1.06 per round. That means when you add up all the people that win and all the people that lose, that's your average. Number 6 is just practice using the table in the back of the book. You can find the binomial table in the back of the book on page 638 to 643. So for part A, you find where n equals 2, p equals 0.30, and x equals 1, and find that probability. I'll let you do the rest by yourself. Here you're supposed to use the binomial formula. Part A, n equals 6, x equals 3, p equals 0.03. Here's the binomial formula, so I'm just going to sub all these numbers in. First, though, I need to figure out what q is. If If the probability that the event happened is 0.03 or 3%, Q is the probability that it didn't happen. 97%, 0.97. I just do 1 minus 0.03. Then I'll just sub my numbers in. 6C3 times P, 0.03, to the x power, to the third power, times Q, 0.97, to the n minus x. So n minus x, 6 minus 3, that'll be 3. These two numbers should always add up to be 1, because it's the probability of the event happening and not happening. And these two numbers should always add up to be n, which they do. So then I'll just put this into my calculator. I get 0.0005. I'll pick one more to do. The others are just the same. I'll do part C. So n is equal to 5, x is equal to 3, p is equal to 0.63. First thing we have to figure out is q. If the probability of the event happening is 0.63 or 63%, the probability that it doesn't happen will be 1 minus that, or 0.37. So now I'm ready to plug it into my formula here. NCX, so 5C3 times p to the x, so that's 0.63 to the third power, times q to the n minus x, so q, 0.37, to the n minus x. N minus x is 2 to the second power. I've got 5C3 times 0.63 to the third times 0.37 to the second power. So I'll put that into my calculator. And I get 0.342. B and D are worked similarly. You do not have to do part E. A student takes a 10-question multiple choice exam. That means that my N is going to be 10. My X. Find the probability of guessing at least 6 correct. If it was exactly 6 correct, my X would be 6. But I'm actually going to have to do, for at least 6, that means 6 or more. So I'm going to have to do 6, 7, 8, 9, and 10. I'll have to do all of those. I'm thinking that the table in the back of the book is going to be the best way to do this. Next, P. What's the probability on just one of the choices of getting it guessed correctly? Well, each question has 5 choices, so the probability that I guess correctly on any given question is 1/5. I like to use 0.2. So then what's the Q going to be? If the probability that I guess right is 1 out of 5, the probability that I'm not going to guess right is 4 out of 5. Or 0.8. So now I'm going to go back to the book. In the back, at my tables that we looked earlier, I'm going to find the probability that x is 6, and then add that to the probability that it's 7, and so on. So for P of 6, my N will be 10, my X will be 6, and my P will be 0.2. I'll find the probability of that situation. Then I'll do the probability of X being 7, so that will be N equals 10. This time the X is 7, but still my probability is 0.2. And so on. So you go to the back of your book, page 638 to 643, and find those probabilities. In the back of the book, For x equals 6, I get 0.006. For x is 7, I get 0.001. For the rest of them, there's no value listed. That means it was too small even count. So I add those up and I 0.007. So the probability of guessing at least 6 correct questions or 6 or more correct answers is 0.007. Problem 11. 40% of Americans do not think having a college education is important to succeed in the business world. If a sample of 5 Americans is selected, find these probabilities. A, exactly 2 people will agree with that. So we need to find these 4 things. And technically, if we're going to use the table, which I'm going to do in the back of the book, we don't even need Q, but I'll kind of leave it there just in case, just so we can talk about it. If you're going to use the table, you need to look up in the back of your book Appendix C, and then find Table B, and at the top it should say Binomial Distribution. You should see the N, the X, and the P for all your choices. So what's our N? Total number of trials. Well, we're going to sample 5 Americans, so we're looking at finding 5 people. And X, the number of successes, exactly 2 people will agree. So X is 2. And P, what's the probability of that? 0.4. It told us 40%, 0.4. To use our table, we don't need Q. What would Q be, though, if we wanted to use our formula instead? 1 minus 0.4 or 0.6. If 40% of the people agree, 60% don't agree. We don't need that for using the table, though. So now, go to that table, find N equals 5, find X equals 2, P equals 0.4, and find that probability. Okay, so again, N is 5. Let's skip the X for a minute. P is still 0.4. At most, 3 people will agree. What does that mean? If at most 3 means 3 or less. So you could have 0 people agreeing, 1 person agreeing, 2 people agreeing, or 3. At most 3. So we actually need to do this problem 4 times. 1 for x is 0, 1 for x is 1, 1 for x is 2, 1 for x is 3. So we're going to go to our table and find the probability of x being 0, and the probability of x being 1, and so on. So you go to your table, find N equals 5, X equals 0, P equals 4, and you find the probability that 0 people agree is 0.078, and the probability that 1 person agrees, problem that exactly 2 people agree, we just did this one in part A, and then the probability that 3 people agree. And we add those together. You could also use the complement here, but we'll leave it at that. So now, at least 2 people will agree. Again, our N is 5. Our P is 0.4. What's our X? At least 2 people. So that means 2 or more. So 2 or 3 or 4 or 5. So we need to find the probability that exactly 2 people agree and add it to the probability that exactly 3 people agree and the probability that exactly 4 people will agree plus the probability that 5 people will agree. This is hard if you're using the formula because you'd have to run through the formula 4 times and add up your results, but it's a lot easier with the table. You just go find N is 5, P is 0.4, and then look up for X equals 2. That's what we did in part A. And then X equals 3. plus x equals 4 plus x equals 5. And we add those together. That's the probability that at least 2 people or 2 or more will agree. Section 5.3, problem number 16. Find the mean, variance, and standard deviation for the number of heads when 10 coins are tossed. The first thing we'd need to know about this is that it is a binomial distribution. It's binomial because we have 2 outcomes that could happen, heads or tails. And then we have 10 coins that are being tossed. So our n is 10. Our x, we don't have an x in this case because it doesn't say find the probability that when 10 coins are tossed, you get a certain number. So we don't know our x, but we don't need that for this. Probability. What's the probability when you toss a coin you're going to get heads? 0.5. So then what's your q? The probability that you don't get heads? 0.5. Or 1 minus p. Where do you go to find these probabilities? That's the hardest part of this one. You go to the chapter 5, and you know that you have a binomial distribution. So you look for mean for the binomial distribution. You see the formula is n times p. And for variance and standard deviation of a binomial, it's n times p times q, and the square root of n times p times q. Make sure you go to your formula sheet and find these. So now we just sub numbers in, n times p, that's 10 times 0.5. N 10 times p 0.5 times q 0.5 is 2.5. And now the square root of 10 times 0.5 times 0.5. We already know 10 times 0.5 times 0.5, that's 2.5. So we just have to do the square root of 2.5. You get about 1.58.